Okay, two triangles are similar, then the lengths of their corresponding altitudes are going to be proportional to the lengths of the corresponding sides. So an altitude, remember, goes from a vertex to the opposite side and makes a right angle. So AD is one of the altitudes of this triangle, or is the altitude marked as in this triangle, and then FJ is the altitude in this triangle. So AD over FJ is equal to AB, a side, over FG. So altitude over altitude, altitude over altitude should be equal to side over side. So again, it doesn't necessarily have to be side AB and FG. It could be equals the ratio of side AC over FH, or it could be equal to the ratio of side CB over HG. Just one of the sides of the triangle, like altitude over the altitude, has to be equal to the ratio of one of the sides over one of the sides. So these are altitudes because they go from the vertex to the opposite side and make a right angle with the side. So in this one, our altitude is X. So you always have to look for a right angle for it to be an altitude. And sometimes your altitude is actually outside of the triangle. So in these two triangles, which are similar by angle, if you notice, angle with one curvy, angle with one curvy, angle with two curvies, angle with two curvies. These two triangles are similar. And then these altitudes are outside of the triangle, so that's okay. So I'm going to do altitude over altitude equals side over side. So X over 7, altitude over altitude, is equal to side over side, and these are isosceles triangles, so it doesn't really matter which one I pick. So 10 over 8. And notice I'm doing left altitude over right altitude, left side over right side. So left over right equals the left side over the right side. Left over right equals left over right. And so now I'm just going to cross multiply. 8x equals 10 times 7 is 70, divide by 8, and x is 8.75, which I did not have to round, and so I'm going to keep, that's my final answer, 8.75.